Welcome to the ftir.fun Infrared Learning Series. This episode Ep37 of Focal Plane Array Imaging, High-Throughput Chemical Imaging. Then close with the checklist. Next, injection. 1 filter, 478 gigs of data, 110,000 microplastics. In 2022, Wang's team from Qingdao University published a study on microplastics from Chinese LCU containers in molecules. Using spaced-Hur whole filter analysis, we identified 110,000 plus microplastic particles on a single 47 mm membrane filter from a single gate of container, with sizes ranging from 11 micrometers to 5 mm. The 6-hour measurement generated info 478 gigs of raw spectral data, automatically processed by a simple software to classify 9 polymer types, JOX, 1J, VNJ. Next, thaw detector from 1,000 measurements to 1 exposure, 1.1 bottleneck of single-point MCT. We call Ep37. Traditional STIR uses a single-point MCT, mercury-cadmium telluride detector. To construct a chemical image, it must perform point-by-point scanning. The Z-stage moves one step, one spectrum is measured, then moves again another spectrum, and so on. Next, eye chemical imaging. Every pixel is a complete spectrum. 2.1 Concept of chemical imaging. Conventional optical imaging, including visible microscope (SEM-ETS), provides morphological information each pixel in a two-dimensional image records a physical quantity, brightness, color, elemental abundance. In contrast, space-infrared chemical imaging is characterized by TPN, text IWIN, data cube, structure of three-dimensional data. 3.1 Definition of data cube. PEM engine produces a three-dimensional data cube, hypercube. Next, FPA, single-point MCT, comprehensive comparison of speed and performance, using scanning a 1 mm times 1 mm area with 5 micrometers step size as a benchmark. bin. Table 4. 5AS single-point MCT speed comparison, Vaseline. 1 square millimeter, 5 micrometers step, 4 centimeters, 128 scans. Next, DPS Case 1 automatic analysis of microplastics on full filter. 5.1 FPA for microplastic detection. Microplastics (AMS) are the most classic application of CPA chemical imaging. Complete on using Agilent 620 plus 620 IRT plus 64 times 64 FPA. In example XC. Next, deeper Heath Case 2 tissue section chemical imaging. 6.1 Why use SPA for tissue imaging? Biological tissues are inherently chemically heterogeneous. A single section contains cells, extracellular matrix, lipid-rich regions, and protein aggregates. Chemical imaging can all be eye. Next, data processing challenges and common tricks. The 4 V challenges of SPA data bulkimation. Volume single experiment GB annual accumulation PB. Velocity single SPA frame generates 25,100 megabytes, requiring real-time processing. Variety. Multi-vendor formats. Multidimensional, spatial plus spectral plus temporal veracity. OSNR, atmospheric interference. Baseline drift require pixel BPM correction. Next, BUV, limitations and future development of SPA-Min. SNR lower than single-point MCT, limited photon flux per pix, unfavorable for weak absorbing samples. Limited waving number. Range most fast cover 4,900 centimeters. Far-infrared 900 centimeters requires special detectors. Visual. Crosstalk exponential signal leakage between adjacent pixels, affecting true resolution. Data explosion. Single experiment GIB level. Storage and processing are. Engineering challenges. High cost. 64 times 64 SPA detector priced at $50,000, 150,000. 128 times 128 even more expensive. Difficulty with Centrotron plus SPA. FPA requires uniform illumination, while synchrotron beam is small and uneven in brightness, requiring special optical design. 8.2 Future development directions. Next, using a 64 x 64 FPA to measure a 47 mm filter requires approximately 19,000 frames to mosaic. Total data volume is 478. Design a data storage and processing plan, including raw data storage strategy, replacing pipeline, and automated report generation. Ep. Tissue section FPA amid-eye center of cancer. Tissue redshifts from 1,654 cm to 1,632 cm. Explain what protein secondary structure change this reflects, and why this change is associated with malignant transformation. Finally, the drill actualists. Make sure you can recall each item. FPA definition. Focal plane array detector turns thousands of measurements into one exposure. Typical array size 32 x 32/64 x 64, 128 x 128, 256 x 256 pixels. Data cube. Y-NT run 3D data. Each pixel has a full infrared spectrum. Speed comparison. FPA 4,100 times faster than single-point MCT, measured. Theoretical 4,096 times. SNR comparison. Single-peak SNR of SPA lower than single-point MCT, low light. Throughput due to small aperture. Chemical imaging presentation. Single-peak chemical map, chemical class map, PK score map. Full filter group for microplastics. Sampling digestion drawing SPN automatic library. Search report. Microplastic tools. Simple offline. OpenSP online open source. Potizo tissue. Data volume 47 mm filter NC 470 requires dedicated processing pipeline. Tissue imaging 8 micrometers frozen section on bond. No aldehyde fixation. Focus on amide-IIT lipids, nucleic acids. Cancer diagnosis. Protein secondary structure changes plus lipid protein ratio plus nucleic acid protein ratio occurs in 90%. Replacing pipeline. And in-spirit correction, baseline correction at correction. Normalization, smoothing feature band selection. Chemometrics, PKOM-CR, PLSS. CNN, deep learning. Main limitations. Low SNR, limited wave number range, ER crosstalk. Large data volume, high cost. Ear competition. QCL laser plus single point detector, higher SNR. Strong competitor to SPA in microplastics. That covers the required stencil for this episode. Practice with real spectra on ftir.fun, and continue with the next lesson.